Thanks, Karis, for the introduction. Hello, everyone, and thank you for joining today. Thank you also to the team at ACDLabs for organizing this symposium and for the opportunity to present today. My name is Kanaka Hetirachi, and I'm going to be discussing the high-throughput purification workflow with the ACDLabs Spectrus platform that we recently implemented at our South San Francisco facility. Today, I intend to present how we're using this software to really enhance our high throughput purification lab operations and also to improve data integrity. So as an outline, I'll take a few slides to explain the background and context for the project. I'll give a brief introduction to the role of a high throughput purification lab in the pharmaceutical industry and give an overview of a typical workflow, as well as business challenges on handling HTP data. Secondly, I will discuss our strategy and vision over the past year in thinking about workflow integration and addressing data management and access. I'll end with an overview of new capabilities that we have with the software and our future plans. So for background and context, for those in attendance unfamiliar with the role of a high throughput purification lab, groups such as ours really exists to eliminate the purification bottleneck by processing crude reaction mixtures submitted from discovery chemistry. So the end result is pure compounds delivered directly to discovery biology or a compound submission lab for shipment to other sites for activity screening. As you can imagine, with a one-stop service, operational efficiencies occur when functions such as purification, evaporation, reformatting of material, purity analysis, and reporting are centralized. So our processes consider many parameters of a purification, such as purity, yield, and throughput. We have substantial investment in specialized workflows and instrumentation and are looking to adapt to new technologies and techniques that can provide even higher levels of productivity. So at this point, I'd like to walk through our primary workflow in South San Francisco. It's worth mentioning that HTP operations vary across the industry. Some groups focus only on purification, while others provide additional services, such as DMSO plate creation, compound storage, and solubility and log D determination. So to begin, from chemistry, we receive a singleton or a library of compounds in a 96-well plate with a crude QC. The determination is then made on method conditions and the type of purification. So for example, either micro or semi-preparative purification with reverse phase liquid chromatography or supercritical fluid chromatography. We employ mass-directed purification to trigger the target isolation with a defined exact mass. So samples are collected into tiered barcoded vials or tubes. And we have large capacity Genovac evaporators that evaporate fractions overnight and serious Gravitrac and multitaskers that can perform weighing tasks. And if necessary, precise liquid handling for dilution, sonicating and vortexing, liquid transfers and reformatting of material. So after this is all done, a final QC is performed and reports are submitted back to the chemist. Clearly, any slow step or instrumentation malfunction in the process can create a bottleneck in terms of throughput. And in addition, the data flow was mostly manual in the past, including the generation of final reports. So as seen in the previous slide, many forms of data are produced on individual computers during each step of the HTTP workflow. And that brings about an important topic regarding data integrity and management. While we know where our data exists on laboratory computers, the challenge remains access to others, specifically discovery chemistry or other analytical groups across the network. So data mining and automatic report generation on a more universal system where users don't really need to worry about where their data resides is helpful to both high-throughput purification as well as chemistry. So here at MSD, we follow the ALCOA requirements for data integrity, where data needs to be attributable, legible, contemporaneous, original, and accurate. And rapid data access and automated analysis will ultimately help accelerate research goals. And data quality will be maintained and protected throughout the life cycle. So strategy and vision. So why ACDLabs for high-throughput purification? Well, to begin with, being able to handle heterogeneous data types from different vendors is becoming increasingly important to our group, as well as handling samples of increasing molecular complexity. So some of the key requirements for an effective laboratory information management system that supports high-throughput purification would be the ability for auto and manual data processing with live data, enhanced search capabilities, automatic creation of customizable reports, and data access through an organized central database containing all the sample information. So although reverse phase liquid chromatography has been the primary method of purification of small molecules from the start of our lab operations, using essentially one single instrument vendor, we've introduced a number of new workflows since then, such as micro-isolation and SFC, and also taken on additional molecular complexity with peptides, proteins, and bioconjugates. So it is essential for our high-throughput purification lab to have an information management system that supports all of these workflows. Okay, so this slide gives an overview of the data handling concept. In the interest of time, I'm going to be very brief here, as I'll cover many of these parts in the upcoming slides. But in essence, there are a lot of things happening in the background, but the entire workflow is fairly seamless from submission, data input, data processing and storage, and ultimately final reporting. So we worked with ACDLabs to develop custom scripts that can handle sample submissions and analysis conditions for high-throughput purification. The Spectrus processor interface has been modified with specific buttons in the main toolbar. Clicking on either loads specific pop-up windows with different drop-down menus, free text fields, and file input areas. So the submission form contains areas for chemists to select their user ID, number of samples, notes that will appear in the email body, SD and crude analytical file locations, and date. So an email will be sent to HTTP regarding the submission, and the attached files will be sent to the appropriate folder locations in a shared drive. The purity analysis form is exclusive to our HTP group, where we designate locations of the purification results, weights, and analytical data files with additional fields for detector lag and wavelength parameters. In the other tabs, we can specify detection, peak detection, integration, processing time ranges, and IntelliTarget parameters for structure matching. Clicking OK will process the data, and upon completion, a database file will be output. Okay, so to be more specific, data from multiple instruments reside in different locations. And so with the locations defined, the purity analysis script imports the relevant files and data into a combined processed database file. The Spectrus DB window contains a customizable visual interface of the entire record with SD file structures, all metadata, including the purification results that include information about the method, barcode, robot weight data, and the final analyzed UV-MS raw files. So each well plate refers to a data set, which is essentially a barcoded fraction. And the required purity coloration scheme can be adjusted for any project. So by default, we have any sample with a purity of 90% and above showing up as green in the plate view. Okay, so capabilities and road ahead. So as I mentioned earlier, ACDLabs Spectrus automatically processes data based on defined analysis parameters, but it is very easy to process data manually, such as performing integrations to get a more accurate purity value when automatic integration needs to be adjusted. So in this database, you can see that well 3 is red, indicating it has a low purity value due to the depth of integration with respect to the baseline from automatic processing. So since we want to modify this integration, clicking on the spectra allows for various manual peak detection choices with adjustments of nodes for peak width, height, and baseline level. After finalization, one can update the database with changes to these integration values. So there is an update button at the bottom, and this will update all the metadata, including having a new purity value for the sample. Okay, and assigning peaks manually is especially useful for more complex molecules, such as large peptides, where perhaps the parent mass is defined in the SD file, but in the actual analyses, perhaps the M/3Z is more prevalent. So in this case, a component match would be false, but one can easily click and drag the component appearing in the SD file to the peak of interest, and the match switches to true. So during auto processing, one can also add annotations to the peaks of interest, such as saying peak 1 or peak 2. Okay, so assigning NMR data. If we had NMR data to store in the record, or let's say if a chemist wants to revisit an older data set, one can import the assigned NMR proton spectrum with the match to match the database record. It will stay separate from the LC UV-MS data files. And So one can also remove any annotations and assignments integrals within that spectral window. So now advanced search functions are also possible from a number of different ways with the software. To search from metadata, a search data pop-up form enables us to build queries, which can be simple or perhaps more complex using conditional parameters, such as date ranges in this example. These queries can be saved for future use, which is very nice. For a structure search, one can draw and import from ChemDraw or go to a ChemSketch to draw, paste, or even open a mol file. One can then search the open database or define multiple databases and use the bottom toolbar for exact structure, similar structures based on similarity parameters, or substructure search. So as you can imagine, the power of search is significant and will allow us to check for, say, for example, previous method conditions. For example, if successful separations have been performed with a particular chiral column, or perhaps if an impurity exists in any past data. So these are all things that are very useful for our group. After data review is complete for the entire record, clicking on the Create Files button enables a final PDF summary report to be automatically created, containing essentially all the relevant sample and chromatography information, as well as a registration SD file that contains the headers, which include barcode, purity, and weight data. So this report file can be saved in the appropriate ELN page. And I should note that with the plate view, there is flexibility to select and only report a select number of fractions, say, for example, those of only high purity or the entire database record. And the registration SD file can be uploaded to our batch registration system. Both files are sent by the software via email to the submitting chemist when clicking on the Send Files button. Okay, so regarding the road ahead, we plan to investigate integrations with existing company software in research, and also to explore enhanced database capabilities and security, and investigate cross-departmental usage, and also to make use of new insights from historical data. So I'd like to end by acknowledging a lot of people for their support the past few years, including at MSD, the High-Throughput Purification Group, Discovery Chemistry, Informatics, and lab computing. Also, a special thanks to the ACD team members for their help in making this initial concept into a reality. And so with that, thanks for your attention.